For centuries, we've been asking this huge question. Is the universe just a giant, predictable machine ticking along like clockwork? Or is it more of a cosmic casino, a game of pure chance? Well, today, we're going to explore the two massive scientific ideas that sit on opposite sides of this epic debate.
So let's get right to it. Is the future already written, or is it just a roll of the dice? This is the central question, and it really pits two revolutionary theories against each other. One suggests a world of incredible hidden order, while the other points to a reality built on nothing but probability.
Okay, so in one corner, we have chaos theory. Now, this theory suggests that even behind the wildest, most unpredictable things you can imagine, there's a hidden, super complex set of rules. It's basically saying the future is already set in stone, we just can't possibly know all the tiny little variables needed to actually predict it. And in the other corner, we have our second contender, quantum mechanics. And this one, well, it argues something completely different. It says that at its very core, the universe runs on pure, uncut chance. We're not talking about something that's just hard to predict. We're talking about something that is fundamentally undecided until the very last second. All right, let's start with our first contender, shall we? This is an idea that honestly finds some breathtaking order in what looks like total, absolute chaos. So let's dive into the world of chaos theory. This quote from Edward Lorenz, one of the pioneers of this whole field, really gets to the heart of it. He's completely redefining what we mean by chaos. It's not true randomness. It's what he calls apparent randomness. So you have a system that looks totally unpredictable, but underneath it all, it's actually following very specific, very precise rules. So here's the crucial point. Think about something like the weather. It seems totally impossible to predict perfectly, right? Well, chaos theory says that's just a problem with our measurements. It's not that it's truly random. It's just that our instruments aren't good enough to capture the starting point with the almost godlike accuracy you'd need. The outcome is already written, we just can't read the script. Okay, a great way to wrap your head around this is to think about a pinball machine. When you pull back that plunger and launch the ball, its path is completely set by the laws of physics. Gravity, collisions, all that stuff. But, and this is the kicker, a tiny, tiny change in how you launched it, like a millionth of a degree, will create a completely different path. But here's the thing, that new path is also completely determined. And of course, this leads us to the famous idea of the butterfly effect. You know the one. A butterfly flaps its wings in Brazil and, in principle, could set off a tornado in Texas. It's the perfect symbol for how a tiny, tiny event can snowball into something massive. But the key thing to remember within chaos theory is that this whole chain reaction isn't random at all. It's a deterministic domino effect that's just way too complex for us to follow. Okay, so now let's turn to our second contender, which makes a claim that is, well, it's way more radical. What if the universe isn't just hard for us to predict? What if it's fundamentally undecided? This is where the Copenhagen interpretation of quantum mechanics comes in. And it says this has nothing to do with our bad measurements. No, it suggests that down at the subatomic level, a particle can actually exist in a kind of blur of multiple states all at once. It's called superposition. And it stays that way until it's measured. So the outcome isn't just unknown to us, it literally doesn't exist yet. And you know who really hated this idea? Albert Einstein. His famous line, "God does not play at dice," just perfectly captures his deep, deep resistance to a universe run by chance. For Einstein, if reality was just probabilistic, it meant our physics was incomplete. He was convinced there had to be some deeper, deterministic layer that we just hadn't discovered yet. And nothing, I mean nothing, captures just how bizarre this all is, better than the famous Schrödinger's cat experiment. It's a thought experiment, of course. But imagine a cat in a box whose fate is tied to the random decay of a single atom. Until you open that box to look, the atom is in a superposition. It's both decayed and not decayed, which means, impossibly, the cat is considered both alive and dead at the same time. The reality of it isn't decided until someone actually observes it. So this huge conflict, this clash between a hidden, clockwork universe and one built on pure chance, wasn't just a philosophical debate. Nope, it led to a brilliant theoretical showdown that, amazingly, could actually be tested in the real world. So was all this quantum randomness just a big illusion? Einstein's camp was really hoping so. The idea they came up with was that maybe particles carry around secret instructions, they called them hidden variables, that tell them what to do from the very beginning. The thought was, if we could just find those hidden rules, boom, determinism would be back and quantum mechanics would just be a theory that didn't have the whole story. Now, this was a very specific attempt to save that old idea of a clockwork universe. The theory said that these hidden instructions had to be local. And all that means is that a particle could only be influenced by its immediate surroundings. No weird, spooky, faster-than-light messages zipping across the cosmos. Everything had to play by the local rules.
And then, in the 1960s, everything changed. A physicist named John Bell came along and devised this absolutely brilliant mathematical theorem. What it did was give us a way to finally design a real experiment to settle the debate. It would force a choice between Einstein's local hidden variables and the seriously strange predictions of quantum mechanics.
And what he came up with was basically an intellectual knockout punch. Bell's theorem proved that you simply can't have it both ways. He showed that any theory based on hidden, preset rules would have to do one of two things. Either it would disagree with the proven predictions of quantum mechanics, or it would have to allow for what Einstein called spooky action at a distance, that instantaneous connection between particles, no matter how far apart they are. You had to pick one.
So this is where the rubber meets the road. The experiments based on Bell's theorem have been run, not just once, but over and over and over again. And the results? They're in. And they are overwhelming. Reality, as far as we can possibly test it, behaves exactly like quantum mechanics says it should. Which means those local, hidden, predetermined rules, they're out.
So, if chance won, if the cosmic lottery is real, what does that actually mean for how we understand the universe and, our place in it?
This quote from the physicist Louis de Broglie, it really gets right to the core of it. What he's saying is that we aren't just passive observers looking at a universe that's already there. The very act of us looking, of us measuring something, actually helps create the reality from that sea of possibilities. And really, that's the ultimate takeaway here. In this quantum world, that blur of possibilities isn't just because we don't have enough information. It's not a measure of our ignorance. According to our best science, it is a fundamental, genuine feature of the universe. At its most basic level, it really does seem to be a game of chance. Which leaves us with one final, pretty mind-bending question to chew on. If the very foundation of our universe is built on chance, not certainty, what does that mean for you, for your choices, for the life you live every single day?